So this is me. I love talking to people, love emailing with people, so feel free to email me or connect to me on LinkedIn or tweet at me or whatever. One thing, I don't really watch direct messages on Twitter, so prefer email instead. So this is a story about once upon a time before I founded Vivid Cortex, which I'm the founder and CEO of now. I ran the consulting team and the support team and a whole bunch of other things at Percona, which many of you probably know. And this is not, sort of a story about the internals of what was happening in the consulting team at Percona so much as it is about how I realized how I was causing problems for the Percona consulting team and how I did that. So I managed a few teams of consultants. We were divided in various ways. It's a global team, so there were people in Europe and people in Far Eastern Russia and people in the Philippines and so forth. And I managed all of these folks, and I managed the support team as well. I don't remember exactly how many people it was, but it was enough. It was enough. I was early at Percona, and when I joined, there were lots of people who were looking for help with scaling problems and so forth. There was really high demand for advice on MySQL performance. And the consulting team was small. So I hired a bunch of consultants, and then things started to get really difficult. And I had to figure out what I was doing to cause that. So this is the story of how I came to understand teams as systems and systems as teams. So a few of the problems that we faced after, I think it was me and the two founders and maybe 3 consultants or something like that when I joined. And not too much later, it was probably close to 20 people. And so these are some of the problems that I started to see. We were struggling with billable time utilization. We couldn't, if you were really working hard, your billable time could be like 30 hours a week, maybe. And we were like, why can't we just, bill 40 hours a week or, at least like 60% or something like that. But nobody could really seem to get their billable time utilization above 50. Sometimes people were down around like 30%, and it felt like they were doing all they could. So that was tough. At the same time, we had high demand, so we were trying to satisfy a lot of billable time demands, and so it was like, this is really, really strange. We had trouble with process and repeatability. We couldn't really predict. Things were very unpredictable, actually. There were times when we had so much demand that customers were calling me and saying, I talked to you a couple of weeks ago, and you said you thought we were going to get to my project, and nobody's even scheduled, nobody has even agreed to work on my project. I mean, when is somebody going to work on my project? And I didn't know, and I couldn't figure it out. The harder I tried to figure it out, the more sort of like I sank into despair. So couldn't predict when anybody was going to get to anything. And then there were these cycles of too much. There was like way too much to do, and customers really unhappy. And then suddenly, the consultants would all be like, Baron, we have nothing to do. There's no customers who need anything to do. And since I was the salesperson as well, I'd be like, okay, I'll just go into sales and, respond to some customers and drum up some business, or I'll call back some people that we had done some work for a couple of weeks ago and ask them if they need anything. And boom, I'd solve the problem, I thought. But spoiler alert, I was causing the problem. So in the middle of this, I was talking with Carey Millsap, the author of Oracle Performance Optimization, an O'Reilly book. And he suggested, I don't know apropos of what, that I read this book called The Goal by Eliyahu Goldratt. And actually, I guess it's Eliyahu Goldratt. And so in this talk, I'm gonna tell a story about how I read that book and started to see everything that was in that book in what I was doing with the consulting team and how we were interacting with customers and so forth. And the lesson that has taught me, and the sort of like you can't unsee, once you see a system in things, once you see a process in things, you can't unsee it. And I've seen it in everything that I've done until today. I'm still learning these lessons. I'm now running sales at Vivid Cortex, and for the last few months, I have been shifting people's roles around and specializing people to avoid some of the very same problems that back in 2008 I was dealing with. So let's dig right into that. After I read The Goal, let me skip ahead to this slide so you can see the cover. Next to the Phoenix Project, which is a similar book. How many people have read The Goal? Okay, and how many people have read the Phoenix Project? And both. Okay, so a few hands. The Phoenix Project makes references to the goal, and it's, I would say, heavily inspired by it. If you disagree, this is a good point to raise your hand and shout. I'd say it's heavily inspired by the goal, and the character in the Phoenix Project makes references to like what happens in the characters in the goal and so forth. So there's the covers. So I'll skip back to my other slide. After I read this book, it was like I got a copy of the book, as Carrie suggested, and then I got on a plane to fly to Barcelona, of all places, for a consulting team meeting. And on the plane ride over, I was just scribbling in every piece of paper. I used up all of my little scraps of paper. I didn't have a notebook. I was writing on the napkins, pressing the service button probably and getting more napkins. It was like almost manic. I kept turning pages and thinking of, oh yeah, there's this other thing, that this relates to, and I was writing all these notes down. I was super excited. It was a little harder to transmit that excitement to other people, because when I get nerding out on something, my enthusiasm might be a little bit over the top. But what it gave me there that I was really looking for was like some glimmer of understanding and some glimmer of hope that there were tractable problems here. Not like, there was a glorious end-all, be-all, and then, there were halos and light beams or something, but just like there was something I could do, because I was kind of at my wit's end. I didn't know what I could do. So I had, some concrete things that I could try. So the goal is a novel about people and systems. The main character, Alex, is running this factory. It's not an IT-driven factory. It's just a factory. They're making parts and things like that. They have the best technology, they have great customers, there's lots of market demand, they have great people, there's nothing wrong except that they're not making money. And whoever Alex's boss is, I forget, calls him up and he's like, Alex, you have 3 months. Otherwise I'm shutting your whole factory down, or something drastic was going to happen in 3 months. He was either going to get fired or they were going to shut the whole thing down. And so he bumps into this guy who becomes a mentor, and the mentor is like very Socrates-like, won't answer any questions. He just asks more questions. It's kind of infuriating. Alex is a little bit frustrated, but he asks questions like, what's the point of your business? Like, what's the purpose of this factory? And Alex is like, to make parts. And the guy's like, no. So eventually he figures it out and doesn't get divorced in the meantime. But I think there was maybe some drama around that and stuff. So it's a novel. I mean, it's very readable. At times it's a little bit over the top. You have to sort of suspension of disbelief and dig into it. But it's really about business process optimization. And this book is required reading in many MBA programs. I bet there's probably not an MBA program that doesn't have it in some curriculum somewhere. And a lot of people have remarked, I think, to me over the years, oh yeah, you like the goal too. Yeah, this whole DevOps thing, it's just a retread of the goal. These people who are interested in DevOps, I think DevOps is more than just the goal, but there's definitely common themes here, right? So Alex's big number one question was, what is the goal of your business? And I'm not going to, be like Socrates and drive you crazy with this. I'll just get to it. So you won't even need to get the book and read the novel. That's not true. You should get the book. It's a good read. So the goal of the business is to make money. And I'm not quite sure why it takes so long to get to that. But it's to make money. It's not like to make parts or whatever. And the goal of his factory was to make money too. It wasn't like to increase efficiency. He was going through all of these different things. But specifically, he kind of boils it down to a very specific little stanza. To make money by increasing net profit while simultaneously increasing the return on investment and simultaneously increasing cash flow. So it's all about money. Like the units of all of these things are money, money, money. And that might sound really capitalistic. So this might be a talk that sounds extremely capitalistic and extremely system-oriented. And just to reassure you, I do care about people too. It's not all about dollars and processes. But it is, if we're not making money in business, we don't have a business. And we can't do all of the other things we want to do. We can't work for good. We can't employ people, et cetera, et cetera. So it definitely has to be about money, at least at some level. And we do that. How do we do that? How do we increase net profit and all of those other things? We do that by increasing throughput, by simultaneously reducing inventory, and simultaneously reducing the operating expense. And these are specific terms that are all also in units of money. So throughput is generated by sales. Throughput is when you sell something. Throughput in computer systems, of course, is when, let's say, a request completes or something like that. One of the things that I took away from this, and I'll encourage you not to get sort of too, what's the word I'm looking for, like tunnel vision on it like I do and think of it all as systems and all as businesses. But one of the things that I took away from it is that you can apply this thinking to everything. Every subunit in the business has the same goals as the business, which is what Alex was kind of struggling with, thinking that his factory didn't have the goal of making money just like the business. Because his factory was just one unit in a larger business, right? So all of these things have units of money, and you can think about anything that you do in units of money as well. Whatever your work is, whatever your processes are, you can, if you choose to, think about them in terms of money. So we can think about the money spent for a web request and the money earned by a web request. So the way we do this, achieve the goal of the business, is to increase throughput, which is the dollars earned through sales, while simultaneously reducing inventory and simultaneously reducing the operating expense. So throughput is the rate at which you generate money through sales. I got ahead of myself. Inventory is the money you invested in things that you've purchased to sell. Inventory can also be thought of as work in progress. It's something that you've spent money on that you haven't earned back yet. So it could be a feature that you've started working on and you haven't shipped to customers yet. It could be something personal even. And operating expense is the money that you spend to turn inventory into throughput. Right, so operating expense is your time working on that feature that you haven't shipped yet. It is your time filling out expense reports. It's the leakage out of the system. It's the money leaking out of the system. So if businesses are systems to produce money, then you have this system, the business, and you have money entering the business, and you have money contained inside the business and money leaving the business. So the sales generate demand into the system, into the business, and your inventory is money that you've invested and haven't gotten anything in return for yet, and then the operating expense. I sometimes think of this as being like a bathtub. It's not a very good analogy because a bathtub is a fixed size, but if you want to fill the bathtub, you got to stop the drain and turn the tap open wide, right? You also want to take all the sponges and toys out of it. Those would be your money getting sort of your water getting absorbed into the system instead of turning into net profit. So achieving the goal is to maximize throughput, which is money in, minimize inventory, which is the money absorbed, and minimize the operating expenses, which is the money out. So let's talk about business optimization. How do you, in the position of somebody who's struggling with, let's say, a consulting team or a factory unit, or you're trying to ship features on time, that was one of the big things that was happening to Alex in his factory. He's always missing deadlines. Like, they cannot get parts out of the factory on time, so their customers are canceling orders and so forth. That's why he's losing money, because even though he has the best people and the best technology, he's missing his deadlines. So how do you, in a situation where you're struggling to actually achieve things on time and on budget, and with the required quality, how do you do that when it's a tough system and you're trying to optimize it? To do that, the goal introduces this thing called the theory of constraints. And the theory of constraints is that there are two primary constraints that are slowing down or holding back any step in your processes, whether it's writing the code or testing the code or shipping the code to production, or documenting the code or announcing it on a blog post or whatever it is. There are two things that slow those things down and make them more expensive and make them less able to handle the demand that sales can place on the business. And then you identify your constraints, and then you work to optimize the processes around those constraints so that you can amplify the inputs without overwhelming the system, process, company, team, whatever, with demand. So if we go back to the consulting team, anytime I would go back into the backlog of customer conversations or prospect conversations and say, yeah, we can do this job for you. Let's go ahead and get a contract signed and so forth. I would commit us to some work, and then a short time later, we would have too much work to do. So the whole team couldn't do the work. So that's kind of, it's very similar. It's exactly similar to web servers that are overloaded, for example. So you work to solve these bottlenecks so that you can increase the inputs for whatever your process is. You can, as an IT team, you can take on more IT projects. You can take on more consulting jobs, whatever it is. So there are two kinds of constraints. There are dependencies, which are either linkages in the process between one thing and another. That would be like an arrow in a flowchart. Or there are events that have to happen before another event happens. So there are dependencies in time, and there are dependencies in the flow of work through the system. It's anything that has to be true before something else can happen. So you can't test the code until you write it. You can't write it until you spec it, in the ideal world. You can't ship it until you QA'd it. You can't deploy it until, right? So all of those things are dependent on one another. If you can model your process, whatever work you're doing as a flow, even if it's not linear, there are dependencies. And then the other kind of constraint is variations. So things fluctuate. Demand is never steady. The rate at which you do your things is never completely steady. And those fluctuations, whenever it's the output of one step fluctuates, whether it's a fluctuation in the amount of time it takes to do that, or a fluctuation in the time at which things arrive. In the perfect world, things would be gated on clock ticks or something like that. But that's not the way that things happen. Things get a little bit delayed, and in the meantime, something else happens. And when whatever is ready, like whenever the code is ready to be deployed to production, the person who's ready to deploy it to production isn't ready anymore. They went home for the day. So it has to wait until tomorrow. So you've got like people dependencies and time dependencies in that example, right? Now I know that all of us deploy our own code. But those are kind of some of the examples of dependencies and variations. And these two things are strongly related because anytime a step is dependent on what's coming before it, then the fluctuations in the preceding step guarantee a fluctuation in the inputs to the next step. So if let's say we have a process that flows from one step to another, and the inputs to the very beginning of the process are extremely regular and predictable. But the process that's handling whatever this is, maybe it's jobs, maybe it's drilling holes in widgets, whatever it is, the process that handles those units of work is variable. So now the output of that step is variable, and the input to the next step is variable. So that's like the baseline fluctuation for step 2. And when you have a baseline fluctuation incoming to step 2, then step 2's output is going to be even, the variations and fluctuations are going to be even more exaggerated there. So this is the only picture I could find of kids sleigh riding. I have 3 brothers, and we had epic hills, and we did epic sledding when I was a kid. And one of the things we tried like 3 or 4 times and then quit was everybody would lay down on their sleds and hold on to the rope from the sled in front of them. And we would line up and go down the hill. And the first person's like chugging along, no problem. The second person gets a little off to the side, and the rope yanks him back. And he overcorrects, and he goes back the other way. So the second person's like jerking around a little bit. Okay, not a serious problem. The third person very quickly just lets go. I mean, it's like shaking a rope, and the tail of it is really is whipping all over the place. That's exactly what happens with these variations, these fluctuations. When you have strongly coupled dependencies in any process or any team, and you introduce variations into them. And there are always variations. So what do you do to stabilize this? Well, one of the things that you can do is decouple a little bit. Probably most of us are familiar with using queuing systems or message buses or things like that to decouple things so that there's asynchronous processing. And what you're really doing is you're basically building up a little buffer where some work can there's a variable amount of space, and you hopefully keep it small, where work can go in and it's not quite ready to be done yet, and that way it can be gated out the other side at a more regular pace. So you can keep whatever is processing that work more fully utilized. So the thing about these buffers, although they're great at helping to smooth out some of the variations and the fluctuations, is that they represent an area where inventory accumulates. So it's stuff that you're paying for, whatever it be. It's stuff that you're paying for and you're not getting value from yet. So you have to be careful about those. The worst thing that you can do, and the thing that Alex had been trying to do in his factory, was look for all the places where there seemed to be excess waste, excess capacity, and trim it to fit the demand. And what you do there is you actually guarantee that the fluctuations are going to get exacerbated. So it looks like you're being efficient and you've got widget processing pipelines and you don't seem to need as many of them as you have. But unless that is actually the bottleneck, you are actually guaranteeing that you're going to create more and more fluctuation and variability, and you will decrease predictability, cut throughput, grow inventory, which is exactly the opposite of what you want to do to achieve your business goals overall, right? So going for efficiency is counter to that. And what I'm really describing here, I'm sure many of you recognize this, is just queuing theory. This is just good old, Amdahl's law, and how can you actually fully utilize your telephone lines, and how many people do you need at the cashiers, and all of that kind of stuff. How long is it going to take you to get your latte at Starbucks? All this queuing theory stuff is it's exactly the same thing, but it's a little bit more intuitive explanation than all of the fancy equations. So in the goal, there's this moment where, I don't know what the occasion is, but he goes out for a hike with his Boy Scout troop. And there's this one little kid who's shorter than everybody else and has a really heavy pack, and his name is Herbie. And tell me if I'm getting this story wrong. I'm sure some of you know this story better than I do. But they're trudging along, and some of the faster kids get impatient, and they take off and go, they go running way ahead. And I was a Boy Scout, and I remember this happening too. We used to do these awful things to kids who would complain about how heavy their packs were. We'd be like, I bet my pack is lighter than yours. Let me take yours for a little while. We would trade packs and then fall back a little bit and put some rocks in the pack and then switch back again. Boy Scouts. Vicious. Anyway, so there's this Boy Scout named Herbie who is clearly the slowest Boy Scout. And the Scoutmaster is back with Herbie, and he's really concerned that the other Scouts are way, way ahead, and he suddenly has this aha moment where he realizes the space along the trail is the inventory, and how fast they're going is the throughput and stuff. And he's like, I need to put Herbie in front and keep everybody packed closely together. And so he gets everybody back, and he's like, Herbie's going in front. And then he's like, but what can I do to make us go faster as a unit? So he takes Herbie's pack off or makes it lighter or whatever. So that's kind of the analogy for how you think about, once you've identified your constraints, which are typically the things that are experiencing 100% utilization and bottlenecking everything. What you do is you actually make that the leader. You make everything in your entire process or organization synchronized to the capacity of whatever your weakest constraint is. And there might be two or more, but usually you should just find one because some of the others might be in disguise. And you place it as the pace setter, and then you try and improve its capacity. And then when you improve its capacity sufficiently, another bottleneck will show up, and I'm sure you're familiar with this. If possible, if you can remove your Herbie, they had this unit at the factory, like yeah, you don't want to remove Herbie from the team. No, but if Herbie is a system, it's okay. So they name one of their units, it's like a heat treating unit or something. They name it Herbie. I think they maybe even paint it with Herbie on the side or something like that. And they figure out how they can get it out of some of their processes and so forth, and remove it as a bottleneck instead of just improving its capacity. And then you look for the next Herbie. And in the Phoenix project, Herbie is named Brent. Brent is like the DBA or ops guy. He's the one who has to be involved in every firefighting incident because he's the only one who can possibly help solve these critical production incidents. What is he doing all the time? He's spending his time on firefighting instead of preventing the next critical production incident. So, find your Brent, find your Herbie, and then really focus on that. So I was Brent, I was Herbie. right, in the consulting team. And I have been many times since then. Too much of the business depended on me. Everything depended on me. It was a consulting company. There were other things in the company besides consulting, but that's where we were earning our money. And there was nobody doing sales. And what was I doing? I was creating massive fluctuations in the system by going and doing some sales, promising a whole bunch of work that was going to have to be done later. We were going to have to do a lot of follow-up. And then everybody would the customers would be calling and be like, Baron, when are people going to get to our work? And I'd be like, wow, there's too much work. I've got to stop doing sales and go back into consulting. And so, of course, what's happening? We're immediately guaranteeing the next overcorrection where there's no work for anybody to do. It sounds almost stupid in hindsight, and it was stupid in hindsight, but I just really could not see it. So, switching back and forth is bad enough, and being the dependency is bad enough, but there was a big gap in the feedback loop. Anybody who's done sales knows that you don't just pick up the phone, and then 20 minutes later you have a consulting job. It takes a while. I don't know what our average time from calling the phone and getting people working on projects was. I wasn't very disciplined about that. I had no idea such things should even be tracked. But I bet you it was in the multiple weeks, even when people were waiting for work. And when there's a long delay, the feedback loop, you really cannot tell whether you are overcommitting or undercommitting or what you're going to do. It reminds me of another example of when I was first learning how to steer a canoe. And I kept running into one riverbank and then the other riverbank. And my uncle was like, you're way overcorrecting. You need to be chilling out back there. And I'm like, but we're going to crash into the riverbanks. And every time I would think that, we would crash into the other one. So anyway, I was definitely causing the problems. And with a long feedback loop, it's really hard not to. So it was kind of the worst of all the worlds. The solution to this, of course, was to get somebody predictably focusing on sales. And so we hired the first salesperson who hired a team. And we had people focusing steadily and consistently on sales. And that doesn't make sales and consulting projects completely perfect, but it makes it a heck of a lot better than what I was doing. So we had this lack of repeatable process as well, and there were a whole bunch of other problems. I can go through a few of them. I think we have enough time. Actually, I'm not sure what time it is now, but it looks like we're about 30 minutes in. Yeah. So we had lack of repeatable processes. We couldn't predict anything. People would do the same job in different ways, and it would take different amounts of time. Also, people with different levels of skill would do the same job, and they would do it the same way, and it would take different amounts of time. So that caused all kinds of fluctuations. So I'm just going to list some of the constraints. I think I had several pages of sort of constraints and dependencies that I found while I was just thinking through this. It turned into a massive email that I don't think anybody else ever read other than me. But there was knowledge sharing. So knowledge sharing, like if somebody was really familiar with a customer and then they went on vacation and the customer needed some help, you had somebody who was going to take longer to come up to speed, was going to have to interact more with the customer, maybe even couldn't do the work. There was also, we were creating a whole bunch of open source software, and not all of it was very well documented. So when customers needed help, this was like early days for extra backup. When customers needed help setting up extra backup to back up their database servers, there were only a few people initially who knew how to do it. They were basically the ones who had written the code. So that was a problem. So it's a dependency. It's not a statistical variation or a fluctuation. It's just a dependency on who can actually do some work. We had time zone differences, had people all over the world, customers all over the world. It's really hard from the East Coast of the US to work on consulting projects in Australia. It's really hard even to work on things from Europe to the East Coast of America, much more so from the West Coast of America. And that's one of the things, as I built the team at Vivid Cortex, I've kept us in the same time zone as much as possible. There's one main exception, but everybody's very closely in one time zone. There are email delays. We actually had this weird thing. I assume this probably is no longer true, but there was a cron job that was taking the emails out of our CRM once every 5 minutes. That doesn't sound like a big deal, But if you've seen the difference in productivity between 1 minute and 5-minute delays, it's huge, absolutely huge. And you would waste a lot of time waiting for a 5-minute delay. You just missed the clock tick and the cron job, and then it would take 5 minutes for the email to get to the customer, and then the customer, of course, would take a few minutes at least, and then they would just miss, and suddenly you've got like a 20-minute feedback loop. Can you imagine? Things like that. There were also interruptions. Customers would have critical issues and would call up, and we'd have to take somebody off of what they were working on and throw chaos into everything. We didn't have some of our prerequisites satisfied, so customers would want help with setting up a database server, and we'd be ready, everything would be scheduled, I'd feel good about it, and then it would turn out that the SSH key and VPN setup hadn't worked, and you couldn't get access to the systems, so you immediately had these enormous delays, and things would, we're talking about slipping for 2 or 5 minutes of work, things would get delayed 2 or 5 days. Or just the availability of a consultant with the required skills, again. Or somebody going on and off of vacation. When somebody is leaving for vacation, you've got to take some time to transfer whatever you're working on to someone else, or you taper off so that you don't promise stuff that has to be, that you're not going to be able to complete before you leave for vacation. And then when you come back, you have no pipeline, you're empty. And it takes a while to get up to speed again. So it's all these kinds of things. All of them were dependencies between people, dependencies across time, dependencies in feedback loops with delays. So it was a huge, huge mess. But just getting myself out of sales probably was, I think, at least half of the problem. At least half. And then some of the other things that we did. Oh, and by the way, in none of this am I implying that Percona doesn't do a good job or anything like that. I hope I'm not sort of like casting stones at Percona, but just reflecting on, as the guy who was managing the consulting team, I was not doing a real good job of it. So getting myself out of sales was a big step. Another thing was specializing the team. We did a couple of team reorgs. One was, instead of me managing teams across functionality, we had teams named after Greek gods. So we had like the Zeus team and so forth. And we had people, the theory was that we were going to get people across multiple time zones working for the same customer so that they always had somebody familiar with their systems, always on all the time. The problem was, none of those people could really have any time zone overlap with each other. And as me managing the people, there was like a team lead for each of those teams, I was causing a lot of problems with everybody's schedules trying to coordinate with people all over the world. So instead of organizing across time zones around the globe, we organized by time zones vertically up and down. So we had one team in Europe, and we had one team in America, and eventually one team in Asia and Pacific, and then there were more teams after that. So that was a big improvement. I kind of, if you had asked me previously, I wouldn't have thought that would make a big improvement. And then another thing was specializing people, so people who were on regular scheduled work were not pulled out of regular scheduled work. And all of the things like getting access to the system, set up, all of these kind of prerequisites and stuff, that was handled by a special team who were basically just completely interrupt-driven. They were watching the emails, they were watching the phones, they were doing small interruptible tasks that didn't have to be done in any specific time, and they were handling emergencies. So suddenly everybody could be booked in longer units of time, 4 hours at a time instead of 15 minutes at a time. And that made a big difference. There was another thing, I had identified all of these things, like 30 or 40 different things that I saw as constraints, dependencies or fluctuations. And in every single one of them, I saw how there was either a potential for improving with process or a potential for helping scale the organization by documenting what was either already the current practice or the best people were doing. So sometimes there were people who were really successful at doing specific things, and by looking at what they were doing and writing that down and turning that into the model for other people, there are big efficiencies to be gained in that. So this book, The E-Myth Revisited, it's another interesting one. It's about something that seems, again, unrelated, sort of how factory systems are maybe not all that related to your continuous delivery pipeline. But but it's really related. This one is about how the lessons that can be learned from franchises such as McDonald's and hotel chains and so forth can apply to any organization, and the benefits that the franchises get out of following really well-documented processes can apply to any organization as well. And you have to do this a little bit with a light touch, otherwise you end up with wikis full of copy-pasted stuff that nobody cares about. You also can end up feeling very bureaucratic, so it's kind of just enough. But having clear descriptions of things and having documented what people's responsibilities are is a huge benefit. So I encourage you to read this one. I think there are lessons for all of us. Whether you're a manager or not, this is not just lessons for managers, it's for individuals as well. So how can you apply some of these things to your organization? Well, I don't know, because I don't know your organizations, but some of the things that I think about, with the engineering team in Vivid Cortex as well as the sales team. I'll just start with the sales team, because that's where my head's been for the last few months. Our first salesperson joined us a year ago, and he does everything from calling and finding customers and setting up demos and giving them contracts and closing. He even goes to the mailbox, gets the checks, and deposits them in the bank. So he is truly end-to-end the whole sales process. However, when he gets busy with something, like when he gets busy with a lot of customers who are in active trials, he gets a little too busy to fill the front of his pipeline. And his pipeline has a big time delay in it. So anything that has a pipeline that has a time delay, it's, your little antennas should go up, danger Will Robinson. If you get busy late in the pipeline, you're neglecting the front. That means that you're going to have a shock wave where you're not going to be busy late, and you're going to go and front load way too much, and you're going to start getting these fluctuations. So in the sales process, there's a book by a guy named Aaron Ross out of Salesforce.com called Predictable Revenue. Predictable. It's about specializing. It's about finding people and training people specifically to do things like calling and emailing prospective customers and filling the front of the pipeline predictably so that at every stage in the pipeline, things remain more predictable. It's very important. I think these principles also apply clearly in the software development process. They definitely apply in the hiring process. I'm going to attest to that. If you are not recruiting now for what you need in 6 months, you're going to find yourself in a tough spot, because good people take a while to recruit. In some cases, I've hired people that I've been recruiting for 3 years, 5 years. There were people I was recruiting in the beginning at Percona who joined after I left. The whole workflow, obviously, of specifying requirements, and I know you think it's a waterfall model, and you shouldn't do like requirements to design, to implementation, to QA, and so forth. But a lot of people do, and really, even in DevOps, where we're doing things in very small batches, it's still small batches of waterfalls. You're just taking the waterfalls and making them smaller. Key things like, who is the Herbie in IT? Most of the time, IT's Herbie is the database administrator and the databases, because of the specialized knowledge. There's a dependency. And because that person can get reactive, can get pulled out of solving tomorrow's problems, and so tomorrow's problems occur. Also, a lot of developers, like this is one of the main things that we do at Vivid Cortex, by helping developers get access to production database visibility. We unbottleneck the developers on the DBA. So the developers are asking the DBA, can you help me with like optimizing this query or whatever? Oftentimes it's because they don't have any access to the information about that query. And so the DBA is busy and can't help them, and they're stuck for a little while. They're waiting for help. That's a big delay. Reducing work in progress, huge. I almost constantly have to just kind of remind myself to look for work in progress. What have we started that we haven't finished? What feature did we complete and close the GitHub issue and not merge? Or we merged it, but nobody deployed it. And a lot of things to solve some of those problems, or we deployed it, but we didn't announce it. A lot of things to solve some of those problems revolve around automation and really shortening that cycle time. A good example is we just moved our website. It's a statically generated site, and we moved it from a Ruby static site generator to one written in Go. And the build times went from about 5 minutes to about 5 seconds, something like that. So in our chat channel, we use chat ops. You can go deploy website to prod, and boom, it's pretty much done. So you can iterate fast on something like a landing page or a new blog post or a fix to something. Whereas before, it was taking several minutes. And that's time when you get bored, you get, in our last talk, we were talking about burnout. Not having control over those kinds of things is actually legitimately frustrating and really, really decreases job satisfaction. You go for your coffee. I mean, you just get so much less done when you have like a 5-minute deploy process or when tests take 5 minutes to run. We use Circle CI for continuous integration. All of that stuff gets triggered whenever you push code to GitHub. Circle runs everything in parallel. It's freaking amazing. I love them. There is no way we could build as fast a CI pipeline as Circle. So do things in small batches. This gets back to reducing work in progress and doing things in small batches and only pulling as much off the backlog as you can actually commit to. It's all like Kanban concepts, right? Make sure people don't have to wait to get their work done. So that kind of concludes what I had planned to talk about, and I think we are at 40 minutes, so I probably need to wrap up. Do I have time for questions? No. Okay. All right, thank you very much.